Ever wondered how quadratic equations work? They may look intimidating, but once you understand their structure, they're not so scary. So buckle up as we delve into the fascinating world of quadratic equations. Imagine a mathematical expression that looks like this: x squared plus bx plus c equals 0. That, dear listeners, is what we call a quadratic equation. It's a second-degree polynomial equation, which simply means it's an equation where the highest power of the variable is 2. But how do we solve such an equation? There are actually several ways to do this. The first method involves factorization. This is where you turn the quadratic equation into two binomial expressions that multiply together to give the original equation. Then you set each binomial equal to 0 and solve for the variable. The second method uses the quadratic formula. This formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, can solve any quadratic equation. It's a handy tool to have in your mathematical arsenal. The third method is called completing the square. It's a method that rewrites the quadratic equation in a perfect square trinomial form. Then you solve for x. But what about the nature of the roots of a quadratic equation? That's determined by the discriminant, which is b squared minus 4ac in the quadratic formula. If the discriminant is positive, the equation has two distinct real roots. If it's 0, the equation has two equal real roots. And if it's negative, the equation has no real roots, but instead has complex roots. And finally, there's the sum and product of roots. For a quadratic equation, x squared plus bx plus c equals 0, the sum of the roots equals negative b divided by a, and the product of the roots equals c divided by a. So there you have it. That's the basics of quadratic equations. From understanding the structure and solving methods to determining the nature of roots and calculating the sum and product of roots, quadratic equations are a great way to stretch your mathematical muscles. Remember, practice makes perfect, so don't shy away from those equations. Embrace them, solve them, and conquer them.